We're talking about lines, slope, etc. All about lines. Number one, can anyone give us the slope definition? Slope given 2 points. And the slope is denoted by lowercase m, and it is a ratio, right? We talked about this before when we looked at the difference quotient, rise over run. So this is y2 minus y1 over x2 minus x1. We discussed that before. Then two equations of lines. We have two. Can anyone give us any of them?
Is it y equals mx plus b?
Y equals mx plus b, which is the slope intercept form.
You're still sharing your screen.
Oh no. Thank you. So sorry. Okay, so R.4, we're talking about lines, slope, and anything connected to parallel and perpendicular lines, anything connected to lines and their slope. And the slope given 2 points, we discussed this when we looked at the difference quotient. This is not new. Nothing here in these R's is new, but you know what I mean. Equations of lines, we have two. We have the slope intercept form, which is y equals mx plus b. And we have one more, which is point slope form. Point slope form. Anyone can tell us or remembers this point slope form?
Is it ax plus by equals c?
Y minus y1 equals the slope times x minus x1. That one is useless. I know you know something, and let me explain what that means. The ax plus by equals c, useless. It's called the general form. How come it's useless? It's useless because I cannot identify the slope. I cannot identify the y-intercept. So it's fine, but I'm never going to ask you this. But you're right. This is the third form. I completely agree. So we do have the slope intercept form. We do have the point slope form, and we do have the general form. Forget about this one. We're not going to use it. We're going to always have to solve for y, either in this form or in this form when we move y1 to the other side. Okay, let's refresh our memory on parallel and perpendicular lines. Anyone remembers parallel, perpendicular lines? So lines, four different types: vertical, horizontal, slant, in different ways. Vertical is this one. Can anyone give us the slope of any vertical line?
Undefined.
Thank you very much. Who was that? Thank you. A vertical line, first of all, is not a function, and it has a slope undefined. Here's horizontal. Anyone other than Nick can tell us what is the slope of the horizontal line?
Isn't it 0?
Excellent, indeed. Slope of a horizontal line. And these are two different types. So this is one type, and this is another type of slant. What type of slope will we have here? And what type of slope we will have here?
Is it positive?
Thank you. And for this one?
Negative.
That's it. Awesome. Great job. Thank you, Zukra. Perfect. Now, parallel and perpendicular. So two parallel lines look like this. These are two parallel lines. And what do we know about the slope of two parallel lines? So this one, let's say, has slope m sub 1, and this one m sub 2. What do we know about the slope of these two?
They're the
The
same.
slope's the same.
Excellent. Perfect. Perpendicular. This is one line. And here's the other. Which means there are 4 90-degree angles here. I'm going to call this line, I'm going to say that this line has a slope m1 and this one has slope m sub 2. What is the relationship between the two slopes if the lines create 4 90-degree angles, in other words, are perpendicular to each other?
They are opposite.
No.
Their slopes are reciprocals.
Negative reciprocals. So m1, m sub 1 is the opposite of 1 over m sub 2. I don't really like this. I'm not going to cross it out. This is what you remember. I am going to cross multiply and say m1 times m2 equals -1. I recommend remember it like this. So much easier than even saying m1 is the negative multiplicative inverse of m2. Just the product is -1. So if this is 1/2, what should this one be to get -1?
-2.
Good. So of course, -4 will give us -2, which is not possible, right? So 1/2 times -2 is -1. What if the first one is -2/3? What should the second one be to get -1?
3/2.
That's it. That is so much easier than plug it in here and then flipping it and then determining m1. The product is -1. It's up to you. Both are acceptable. Both are the same. Okay, I'm going to share my screen. And let's go to page. What is the page? Page. Did I get there or not yet? Slope intercept equation. Okay, we talked about that. Okay, page 44. 41, 42, 43, 44. Okay. And then we're going to talk about demand and supply and the break-even point, the equilibrium point. Yeah. Okay. Good. I hope we don't have to graph any of this, but if you feel like graphing a line, please choose one. That's fine. Please choose.
20.
Very good. So we want to look at 20 on page 44, and we have y minus 3x equals 6. Good pick. So we always have to determine the x and y intercepts. We must note, always, not just for linear, always, including piecewise defined functions, always look for x and y intercepts. For some function, some one or the other may not exist. If I'm going to put in parentheses, if they exist. Okay. So I don't have to solve for y, I don't have to do anything. I will have to determine when x is 0, find y, and find the ordered pair. When y is 0, find x, and write the ordered pair. Don't do anything else. So when x is 0, I cover the term that has x. How much is y?
6.
So if y is 6, can anyone give us the ordered pair? 0, 6, that's it. When y is 0, how do you get x and how much is it?
Divide -2.
Yes, 6 by -3, and I get -2. Who was that?
Jessica.
Thank you. So now I would like to determine the ordered pair. Thank you.
0, -2.
Careful.
Sorry, -2, 0.
Excellent. That's all I need. So I'm going to draw the coordinate system. I'm going to plug 0, 6 in there. 1, 2, 3, 4, 5, 6. I'm going to plug in I'm going to plot -2, 0. I'm going to connect and extend the line. I label the axis of coordinates. I will label the graph always. This is y minus 3x equals 6. I always have to determine the x and y intercepts if they exist. This line is a vertical line. The equation is x equals 0. So I determine the y intercept. This line has the equation y equals 0 is the altitude. Y equals 0. So that's why this was -2, 0, the x-intercept. So the x-axis has the equation y equals 0. The y-axis has the equation x equals 0 because it's a vertical line. Vertical lines have only x. Horizontal lines have only y. Okay, so let's look at a word problem. Or unless you want to determine anything from here, finding the equation, given 2 points. If you want to do that, let's pick, and then let's look at a word problem.
Could we do 50?
50, okay, very good. So in 50 we have one point x comma 3x minus 1, and the other point x plus h 3 in parentheses x plus h minus 1. So here they want find the slope of the line if the slope is undefined state. So just they don't want us to determine the equation, they just want us to find the slope. So imagine that this is point A and this is point B. So this is basically my x sub 1, and this is my y sub 1, and this is my x sub 2, and this is my y sub 2. So they only want us to find the slope. And I will write y2 minus y1 over x2 minus x1, and then enter everything step by step. y2 I will also distribute. Not to -1, careful, only to 3x plus 3h. So 3x plus 3h minus 1. Now minus y1, careful. Minus y1 means this and this will change their sign. So minus 3x and plus 1. Now with x2 minus x1, x2 is x plus h, minus x1, which is x. And of course, I'll try to simplify everything as much as possible. Lucky me, look at this. The 3x with a -3x, the -1 with a +1, the positive x with a -x. And I get 3h over h. Only now I can simplify because these are factors. And the answer is the slope of this line is 3. Good pick. Any questions? Anyone? Any questions?
No.
Okay, let me know. So now finally let's take a look at some word problems with linear functions. This is the most important. So one type of situation that I would like to look at is find the average rate of change. This is very important to discuss. We already discussed it with something way more sophisticated, which is the difference quotient. But now let's look at the average rate of change for any. So that's one problem that I would like to look at. Of course, you can pick anything you want. Then I would like to look at something like this, the stopping distance on glare ice. Something that's a linear function. We can see it here, right here, linear function. It's like f of x equals 2x plus 115. Okay, median age of women at first marriage, something like that. Okay, and then we can stop after that. So, although you see here a fraction, this is not a rational function because it doesn't have the variable in the denominator. This is 11 over 10r plus 5 over 10. This is a linear function. It's not rational. It has a fraction line, but it does not. That's not. If it doesn't have the variable in the denominator, it's not a rational function. Okay, I'm ready. When you are ready to pick, we'll continue. So you want to talk about the stopping distance? You want to talk about the reaction time?
Let's do 83.
Okay, perfect. 83. So let me write the page number so you always have that. Hey, 83, what was it? 47. Okay, perfect. I know I'm still on the shared, but let me just copy. So d of r equals 11r plus 5 divided by 10. And it says while driving a car, you see a child suddenly. Your brain registers the emergency and sends a signal. Yes, we really hope so. The car travels a reaction distance. D, I take notes. Reaction distance. Okay, and this is in feet. Then R is in miles per hour. R, speed in miles per hour. Okay. The car is traveling when you see the child. Okay. The reaction time, they give us the linear function. In part A, they want us d of 5, d of 10, d of 20, d of 50, d of 65. Then they want us to graph d of r. And then what is the domain of this function? Perfect. So part C, domain. Let's start with part C because that's the easiest. Can anyone give us the domain of this function in a blink?
All real numbers.
Of course, it's a linear function. Linear functions are friendly. There is nothing, no problem. They never create any problems. Perfect.